This unstable crystalline structure, constantly fracturing and rebuilding itself, represents how general-purpose large language models behave in professional environments. Their probabilistic nature causes multi-step workflows to collapse under their own weight. An off-the-shelf AI might write a passable paragraph, but it lacks the stability to manage complex, interconnected business logic without hallucinating variables or losing context. In a professional environment, a probabilistic guess is a liability. When bad data translates to lost revenue, users demand exact, repeatable outputs. This requirement for precision drives the architecture of Lois 24/7. It is a specialized software platform engineered to automate the intricate daily workflows of professional stage speakers. The engineering challenge lies in the extreme operational variance of this profession. Tasks range from generating RFP proposals to AV tech sheets, executing email campaigns, and calculating contract profit margins. Solving for that variance requires discarding the standard open-ended chat interface in favor of hard-coded architectural constraints that force the AI to behave deterministically. Horizontal AI tools attempt to answer any prompt a user can imagine. Vertical AI systems are rigidly constrained to serve a single niche perfectly. Lois 24/7 operates as a vertical AI by limiting exactly what the user is allowed to ask the system to do. The platform's architecture relies on an extensive middleware layer to manage every interaction. This layer coordinates roughly 200 serverless functions to ensure the underlying language model produces deterministic results rather than probabilistic guesses. To understand how to build reliable AI for professional environments, we have to deconstruct this application layer by layer, starting with how it translates a chaotic human workflow into rigid code. This diagram shows the first layer. We funnel a speaker's chaotic workflows into a rigid programmatic matrix. The system divides their lifecycle into 4 phases: research, create, sell, deliver. These hard code into 32 folders called skills, locking down logic rules before processing. This bypasses the ambiguity of a prompt box. The skill folder automatically injects the correct industry standard template before the AI ever sees the request, removing the need for user-provided context. Forcing user intent through this specific 32-node matrix mathematically eliminates broad-scope ambiguity before a single API call is explicitly constructed. Those 32 abstract skill definitions are atomized further into the execution layer, branching out into exactly 200 execution endpoints. When a user initiates an action, their request locks into one specific Node.js helper function, bypassing the rest of the network. This enforces the single responsibility principle. Each helper function is entirely blind to the rest of the application, executing only its assigned microtask. Within milliseconds, it handles authentication, assembles the contextual prompt, calls Anthropic Claude, saves the response, and formats the JSON output. These helpers also manage dynamic model routing, using a fast AI model for simple formatting tasks, and selectively routing to a robust model only when the logic is complex. These 200 isolated helpers act as the crucial middleware. They transform the inherently probabilistic text generation of a language model into deterministic software execution. Because the core AI logic is isolated within the backend helpers, the presentation layer of Lois 24/7 is entirely decoupled. This allows the same backend logic to power the primary React and Vite-based web application. It also enables alternative client interfaces to plug into these same endpoints, such as a Chrome extension or a native Gmail integration. The system exposes this logic externally through partner pages, connecting the isolated endpoints to 16 third-party applications like Canva and MailChimp. Access control and monetization are handled centrally via Stripe, gating all available tools based firmly on the user's current subscription tier. Isolating the AI execution from the user interface allows a single engineering effort to deploy complex features across an omni-channel ecosystem without duplicating code. Keeping a fragmented 200 endpoint architecture responsive requires a rigid production infrastructure. The backend relies on serverless functions deployed through Vercel. The data persistence layer uses DynamoDB for high-speed structured memory, AWS S3 for raw file blobs, and SES for routing automated email campaigns. The system incorporates specialized audio augmentation through AWS Poly, integrated directly into the helper endpoints to convert Claude's text output into synthesized speech. Relying on third-party language models requires aggressive automated testing. The codebase contains 580 distinct test files that run continuously to prevent logic regressions. In production, an automated script pings the live site every 5 minutes. If an unexpected hallucination breaks the data pipeline, the system instantly routes an alarm through Sentry. Without this aggressive monitoring and automated testing, a complex multi-agent AI system will collapse under the weight of unforeseen edge cases and model updates. To see this architecture working in unison, we can trace the complete lifecycle of a request, such as generating a stage booking pack. This diagram illustrates the 4 stacked layers of the system. The trigger originates in the user's browser. The request drops into the skill routing matrix, finding the exact operational context for a booking pack. The request isolates further into the helper grid, locking into the specific Node.js helper designed exclusively for assembling these packs. That helper fires simultaneous calls to the foundation layer, authenticating the user via clerk, fetching historical state from DynamoDB, and transmitting the constrained prompt to Anthropic Claude. This routing lifecycle ensures that the generated RFPs, checklists, and tech sheets are mathematically bound to the user's historical data. The primary architectural takeaway of Lois 24/7 is that successful enterprise AI products are rarely defined by the raw power of their underlying foundation models. Because the architecture is atomized into 200 discrete helpers, engineers can swap out the underlying language model in the future without breaking the core application. The enterprise value is created by the middleware. Rigid logic and isolated serverless functions are what force the language model to behave predictably. To serve professional user bases effectively, developers must move away from open-ended chat interfaces that rely on the user to engineer the right prompt. In the end, high-utility software engineering now requires mapping complex human workflows into highly constrained, single-responsibility execution pipelines.